we'll be talking about rational exponents. And if you remember, a rational number is one that can be written as a fraction. So when we're talking about rational exponents, we're talking about exponents that are fractions. So the general rule for dealing with rational exponents is going to be this. A to the power of m over n, so a fraction, is equal to the nth root of a to the power of m. So the way the rule works, when you look at the expression in exponential form, we want to switch it into radical form. In exponential form, it has these three parts: the base, and then the numerator and denominator of the exponent. When we switch it into radical form, the base of the exponent becomes which part of the radical expression? Is it the radicand, the index, or the exponent?
I have a question.
The base becomes the radicand. The base in exponential form becomes the radicand. The numerator of the exponent, which is the m, what does it become over here? Is it the index or the exponent? The exponent. And then the denominator, the n, becomes the index. So you have to remember that's how it switches, and you need to be able to take an expression and switch it into the other form. So we want to look at taking the expressions that are in exponential form and switching them into radical form. We have 6 to the power of 1/2. What's that going to look like when we switch it into radical form? So we'll have a square root sign. Where will the 6 go? Inside. It becomes the radicand, right? So it goes there. What about the 1? The 1, the numerator of the exponent, becomes the exponent on the radicand, so it goes there, 1. And the 2 becomes the index, so it goes in here. But actually, if you remember, when we're working with radicals, if the index is 2, we don't usually show it. And if the exponent is 1, we don't show it. So we could actually just write this as root 6. That's how it should actually be written. But to show you where those numbers go, I have that other step. So then if we do the next one, 3 to the power of 4/5, make your radical sign. The 3 goes inside. The 4 becomes the exponent, and the 5 the index. So it's just a matter of following that general rule and putting the numbers where they belong. This one, the -5 to the 1/3, same thing, radical sign, -5 goes inside. If it starts out in brackets, I would keep it in brackets. Usually if it has a negative number, I'll just keep it in brackets. The 1 becomes the exponent, so we're not going to show it. The 3 becomes the index. So it's the cube root of -5. And the last one there, it is in radical form, we're going to put it in exponential form. This becomes 7 to the power of, anybody know? What will the exponent be when we take this radical form and switch it into exponential form? 5/2? Yep. 5/2. The exponent becomes the numerator of the exponent, and the index becomes the denominator. And whenever you don't see an index, you need to know that it's equal to 2. So it's 7 to the power of 5/2. So this one says simplify. Any variables in the final answer should be written with positive exponents. Fractional exponents should be converted to a radical. And that's going to be in general, unless otherwise stated. You're going to want positive exponents and fractional exponents converted to a radical. So let's look at this. We have a few things going on here. Power of a power is the first thing. So what do we have to do with those exponents? Multiply, right. But what's the exponent on the 27 right now? A 1. The 1/2 is just with the a. So we're going to do this. 27 to the power of 1 times 2/3, which is just 2/3. And then a to the power of 1/2 times 2/3, which is 1/3. 2/6, or if you reduce it, 1/3. So now we're going to switch these to radical form. The cube root of 27 squared. Oops. And then the cube root of a. But if you look at that part of it, the cube root of 27 squared, we can actually evaluate that. That's just a number. And when you're doing this, we could either square the 27 and then take the cube root, or take the cube root of 27 and then square it. It doesn't matter which one we choose. Both will give us the same answer. But I'm going to do the cube root of 27 because I know what the cube root of 27 is. Does anybody else know what it is? Cube root of 27. 3. Somebody said it. 3. And then I want to square that. And 3 squared is 9. So this is going to become 9 cube root a. Here's another one. 9a to the negative 2 over 16b to the negative 4, all to the power of, that's negative 3 over 2. One thing that you need to remember is those exponents that are already there that are invisible. 9 is to the power of 1 and 16 is to the power of 1. And then we're going to multiply exponents. Or, yeah, let's do that. There's a couple of different ways we could approach it, but let's do that. So this will become 9 to the power of negative 3 over 2. A to the power of positive 3. It's negative 2 times negative 3 over 2, which is a positive because negative times negative, positive 3. And then 16 to the power of negative 3 over 2. And b to the power of 6. What can I do with the negative exponents? You flip them, right. So I'm going to change this to 16 to the 3 over 2 a cubed. See, the a stays where it is because it has a positive exponent. And I'll put 9 to the power of 3 over 2. And the b to the power of 6 stays where it is because it also has a positive exponent. Now I can evaluate these two. 16 to the power of 3 over 2. Let's take it up here. If I put it in radical form, I can understand that exponent better. In radical form, it's 16, the square root of 16 cubed, right? And the 9 becomes the square root of 9 cubed. So again, I'm going to do the radical part first. Square root of 16 is 4 cubed. And then the square root of 9 is 3, and we'll do 3 cubed. So 4 cubed is 64. And 9 cubed is 27. And there's the final answer. That's it, taking into account almost everything we've done in this unit. Because it's using the exponent laws, including the negative exponents and rational exponents, and radicals is in there. So almost everything in this unit is covered in this one question. First thing we're going to do is divide. Negative 20 divided by 4?
Negative 5.
Negative 5. But then we need to use the quotient law on the variables. So we have a to the power of negative 2/3 divided by a to the power of 1, which means we have to do negative 2/3 subtract 1, which is equal to negative 5/3.
What are you subtracting?
So then we do the same thing with the b's. We have a b to the power of 1 divided by b to the power of negative 1/2, which means we do 1 minus negative 1/2, which is equal to 3/2. B to the power of 3/2. One of those three terms has to go into the denominator. Which one goes to the denominator? The negative 5 stays where it is because the exponent on that is positive 1. The b to the 3/2 stays where it is, but the a has a negative exponent, which means you can switch it into the denominator. We don't want to leave negative exponents in the numerator of a fraction. We always put them to the denominator. And then it says that fractional exponents should be converted to radicals. So this is going to be negative 5 root b cubed over cube root of a to the power of 5. And that's just following that rule that we had at the beginning of class today. All right, this is the last one that I want to look at with you. And if you notice, well, the answer is not 1, but the 0 exponent, what's the rule there? This whole thing equals 1.
So it's irrelevant. Why is it even there?
This part of it that has the exponent of 0 is equal to 1. So now we have 9 to the power of 1/2 times 1 is what this actually simplifies to.
So that's it.
Well, this means it's the square root of 9, which is equal to 3. That whole thing simplifies to 3.
Can I just put 3?